Alright, this is Match 209 and we'll be looking at a method called the Newton-Raphsons method. And so we said in the last time, we said that the Newton-Raphsons method is used, did you see that? Is used to find the isolated roots of an equation. Is used to find the isolated roots of an equation. And so Newton-Raphsons method is one of the clinical methods you can use to find the root of an equation. And so we said that the Newton-Raphsons formula states that for every next term is equal to the previous term minus f of xn all over f prime of xn. This is the Newton-Raphsons iterative scheme, the Newton-Raphsons iterative formula. And so what you use it to find the root of a question. Let's say, for example, we want to find the root of this equation. The equation x to the power of 3 minus 6x plus 4 is equals to 0. Do you see that? We want to find and correct to 4 decimal places. Correct to 4 decimal place. Did you see that? The Newton-Raphsons iterative scheme of x to the power of 3 minus 6x plus 4. And so, first, if a root was not given for this question, normally it's supposed to have a root A or comma B, where you say 1, 0 or 2, 3. You're supposed to have a root for the question. But if the question doesn't come with a root, what then do you do? So we do what's called a try by error. We do what we call try by error. So how do we do the try by error? Let's test for f of 0. F of 0 inside this function is you saying 0 raised to the power of 3 minus 6 into bracket 0 plus 4. And then your answer to that question is 4. F of 0 is 4. Alright? We want to test for f of 1. We are finding the root right now. We want to find two roots. The roots helps us to know where our answer will lie, right? F of 1. And so when we find out, we have 1 to the power of 3 minus 6 into bracket 1 plus 4 equals minus 1. So since this is a positive figure and this is a negative, it has proved Descartes' law. Descartes' law of signs, where you need to have one positive and one negative. Did you see that? The Descartes rule of sign. One positive, one negative. And so the root lies. This means that the root lies between, did you see that? It lies between 0 and 1. 0 and 1. The root lies between 0 and 1. So, to further investigate this, we then need to take account and say, we pick a number. Can I clean up the board? Yes. Let me erase this part. Let's erase this part. And then we say, choosing, you see that? Choosing our x naught to be any value, let's write it, to be any value between 0 and 1, right? So we say x naught will be 0.7. We choose any value between the interval of 0 and 1. We choose any value between the interval of 0 and 1. So we say x naught should be 0.7. Then it means that f of 0.7 will be 0.7 to the power of 3 minus 6 into bracket 0.7, right, plus 4, and then we have it as 0.143. Now that we have this, we can then say, now let's differentiate. The next step is to differentiate the function itself. Remember that Raphsons' law states that the NR law states that xn plus 1 is equal to xn minus f of xn all over f prime of xn. So this f prime connotes differentiation. Remember that the equation itself is x to the power of 3 minus 6x plus 4. And so when you differentiate this function, when you find the f prime of this function, you're going to have 3x squared minus 6. Remember, when you differentiate x to the power of 3, the 3 comes down. So you have 3x squared minus 6. And so f prime is 3x squared minus 6. Alright, so what we are simply saying is that our x0 is equal to 0.7. Our x0 is equal to 0.7. And our x1 will be x0. You see, when you say xn plus 1, that means if we are following a number line like this, and we call this person xn, the next person should be xn plus 1, the next person should be xn plus 2, and so on and so forth. What it simply means is that before you get to this place, the next term is equal to the previous term minus f of the previous term all over f prime of the previous term. So Raphsons is simply saying, whenever you are going to the front, remember where you are coming from. This is where you are coming from, minus f of where you are coming from, which is this person, divided by the differential of where you are coming from. So x1 will be equal to, for you to progress to x1, you remember you are coming from x0. So we say x1 is equal to x0 minus f of x0. Do you see that? All over f prime of x0. That's what the Raphsons is telling you. And so x1 is equal to 0.7, since our x0 is 0.7, minus, what is f of x0? Remember, we have done f of x0 to be 0.143, so 0.143 divided by, what is the differential? Whenever we differentiate this function, f prime of x is 3x squared minus 6. So what will be f prime of 0.7? F prime of 0.7 will be 3 into bracket 0.7 all squared minus 6. So it means that f prime of 0.7 is, if we do that in calculation, that will be 4.53. So we're just going to bring that here, 4.53. We're just going to bring it here and say 4.53. Is that clear? And so x1 is equal to, if you do the math of this, it's going to have 0.7316. Is that clear? 0.7316. And so what do we do next? We said that x2 is equal to x1 minus f of x1 all over f prime of x1. So x2 is equal to, what is x1? What is x1? x1 is what? x1 is 0.7316 minus, now when you place what's it called, when you place this into the question itself, remember the question says that what? The question says x to the power of 3, don't forget, minus 6x plus 4. So when you place this into here, slotting this into here as the equation or the formula implies, when you slot in this into here, that's putting it into the equation itself, you're going to be having okay, let's do that together. Minus 0.7316 all cubed minus 6 into bracket 0.7316 plus 4, all divided by f prime, that's f prime, which is 3x squared minus 6. So we are putting 3 into bracket 0.7316 all squared minus 6, and so we will find the calculator solving of this. Let's solve this together. We have alpha x okay, we have open bracket 0.7316 all to the power of 3. See, that's minus 6 and 6 into bracket 0.7316 close the bracket plus 4. So divide by 3 into brackets 0.7316 all to the power of 2 minus 6. Is that correct? So we have this, so then we have x2 equals 0.7316. This is minus. So this particular function here on the calculator is minus 0.000457071, and so x2 is equal to 0.7316 minus times minus is plus 0.000457071. So we have it as, we have x2 is equal to let's do the calculator of that quickly. We have x2 to be 0.73250699. That will be x2, right? So the fact that we have been able to do this, then we said the question says give this answer in 4 decimal places, and so x2 to 4 decimal places, x2 to 4 decimal places will be 0.73123425 to 4 decimal place. Having said this, then you can now say that the root of the equation x to the power of 3 minus 6x plus 4 is, see that the root is 0.7325 to 4 decimal places. I hope that is clear. Yes, that is clear. Now, having said all of these things, there is a subtopic in Raphsons' law. There is a subtopic where we shall be finding, did you see that? Finding the iterative formula. Finding the iterative formula of square root of a positive number. Finding the iterative formula of square root of a positive number. Raphsons number. So let's find the iterative formula of a positive number. So let's assume that x is equal to the square root of n. Iterative formula of a positive number. So x is equal to the square root of n, and then we find out that what we said, x is equal to n to the power of half. You know, the laws of indices says